Hello everyone, my name is Zishan. You're welcome to Zishan classes. This is the fourth question that we are going to address from the chapter Kinematics, and it's about a block, small block A, moving down an inclined plane. The length of the base of the inclined plane is 2.1 meters and the coefficient of friction between the block and the plane is 0.14. We have to find the angle alpha for which the time of slide is minimum. We have to find the value of alpha for which the time taken by the body to reach the bottom of the inclined plane is the minimum. These are the data, these are the details of the inclined plane that are given to us. Just keep in mind that the length of the base is given to be 2.1 meter and the coefficient of friction is 0.14. So first let us calculate the distance that this body has to travel. Okay, it's going to be given by, let us assume that this distance is equal to S. This distance is equal to S. Let us assume that this distance is equal to S. In this right angle triangle, what we can do is, clearly we can see here that the cos of alpha is going to be equal to L divided by S, which gives us S is equal to L divided by cos of alpha, which is equal to L sec of alpha. So this is one initial step that we have to keep in mind, that the distance traveled by the block, which is represented by S here, will be equal to L sec alpha. Okay. Now let us calculate the time required for the body to reach the bottom. That time obviously will be in the terms of alpha, and then we'll go ahead with it. We are going to use S is equal to ut plus half at square. It starts sliding, it is said in the question, so initial velocity is 0. S will be equal to L sec alpha into half acceleration of the block into t square. Now let us talk about the acceleration of the block. Drawing the free body diagram of this body, we have to use the equation F is equal to ma, where F is going to be equal to mg sine alpha minus mu r, and then ma, which gives us mg sine of alpha minus mu times mg cos of alpha equals ma, which gives us a is equal to g sine of alpha minus mu g cos alpha. We'll keep this aside for our use. We were at L sec alpha equals half a t square, which gives us t square equals 2L sec alpha divided by g sine alpha minus mu g cos of alpha equals, this is 2L divided by cos of alpha. The cos of alpha can be brought down in the denominator and multiplied with these two terms, which gives us 2L divided by g sine alpha cos alpha minus mu g cos square alpha equal to 2L divided by g sine 2 alpha divided by 2 minus mu g cos square alpha is equal to 2L divided by G sine 2 alpha minus 2 mu G cos square alpha whole divided by 2. This 2 here can be taken up in the numerator and multiplied with 2l, which will give us 4l. Now we have got the expression of t in terms of alpha. T square equals 4l T square equals 4l divided by G sine of 2 alpha minus 2 mu G cos square alpha. Okay, now the whole problem was focused on finding the minimum time for a given angle alpha. We have also got a relationship between t and alpha. What we are going to do is to use differentiation to find the value of alpha, for which we have the minimum value of t. For t to be minimum, this expression here should be at its maximum value. To find the maximum value of this or the value of alpha for which this expression has the maximum value, we're gonna have to differentiate this. So differentiating G sine 2 alpha minus 2 mu G cos square alpha with respect to alpha and equating that to 0. The reason is to find the maximum value of an expression, we're going to have to differentiate it and equate it to 0. So now this brings us to This brings us to 2 cos 2 alpha minus 2 mu times 2 cos alpha sin alpha equal to 0. This implies that 2 cos 2 alpha plus 2 mu sin 2 alpha equal to 0. This implies that 2 mu sin 2 alpha is equal to minus 2 times cos 2 alpha, which gives us tan 2 alpha equals minus 1 by mu, and here is where we end at, because this is the value of alpha at which we have the minimum value of t. Also, to this expression there are two solutions. One of them, you will find alpha equal to some negative angle and some positive angle. You have to ignore the negative value and you have to accept the positive value, which gives us alpha is equal to 49 degrees. Now at alpha equals to 49 degree, what you do is put this value in the expression of t and you'll get the minimum time, which comes out to be 1 second, if I remember it correctly. So this is it. This is the end of the solution. Minimum time required was equal to 1 second. Alpha, the angle at which the time is minimum, is 49 degree. And keep in mind, I'm ignoring the basic trigonometric laws of 2 cos alpha, sin alpha being equal to sin 2 alpha, sin 2 alpha divided by cos 2 alpha being equal to tan 2 alpha, and things like that. So I hope you are good at these trigonometric relationships so that we are quick with what the concept is and reach the answer as easily as possible. That's all for now, and we'll look up another good question from the book later. You have a good day. Bye.